let's go ahead and take a look at kind of the main parts of the radians for the unit circle. Obviously, if you want to refer to the whole unit circle, here it is, and you can see these are all the radian measures there, so that'll be a pretty easy thing to reference and help you through this. If not, though, if we're just taking a look at the circle itself right here, let me just center it real quick. Didn't do anything. Okay, so we know that the circumference of the circle, remember the radius of a unit circle is 1, so the circumference is 2 pi r, which in our case is 2 pi, because our radius is 1. So if we start here, right here at this point, 0 is our radians. But if we come around the whole entire unit circle, that will be a total of 2 pi radians. That'll be the circumference of the entire circle. And so what would half of the circle be? So here's kind of another key value. Half of the circle would just be pi. Okay, well, what is a quarter of the circle? Well, it'd be 2 pi over 4, because it's a quarter of it. Or half of pi, which is pi over 4. Two different ways to think of it, right? Half of the half circle is pi over, not pi over 4, pi over 2. My bad, I was jumping it. Because half of this, we're cutting this part in half, which would give us pi over 2. But we're cutting this in fourths, so 2 pi over 4 is also pi over 2. How did we come up with this? Different ways. You can think of it as 3/4 of 2 pi. That might be one way. But just for the sake of this assignment that we're doing here, let's think of it as pi plus a quarter of the circle, or plus this portion here, which we know is pi over 2, right? Quarter of the circle is pi over 2. So think of it that way. We get our common denominator, 2 pi over 2 plus pi over 2, which equals 3 pi over 2. And I like to think of it this way, as taking, you got this half a circle, and we want to add to it the quarter circle to get us there. So we're adding the pi over 2 to it. All right, so in this problem, we want to know what's the x-coordinate. So x-coordinate, remember, is cosine. Let me just write the reference up here. You should have that written down, but in case you didn't. So x is cosine of theta. So we were looking for, on our answer choice here, cosine. So A is out, C is out, and E is out, right? If we're going to do elimination. But what's our theta? What's our angle here in radians? So, well, quarter of the circle, remember, is pi over 2. That's this point. So we're going to add pi over 6 to it. So pi over 2 is this portion here. And then pi over 6, I don't know why I just picked the exact same color, is that portion there. So pi over 2 plus pi over 6 equals, let's get our common denominator. So times it by 3 to get 3 pi over 6, plus times the other one by nothing, already good, pi over 6, for 4 pi over 6. Now we can simplify this, both are divisible by 2 to get 2 pi over 3. So that's our angle, 2 pi over 3. So cosine of 2 pi over 3 will be our answer. Very similar thing here. You have, remember, this is kind of our key spot here. That's going around this circle. That's 3 pi over 2. So we want to add to it pi over 4, right? So get that common denominator. Which is going to be 4. So you're going to multiply it by 2. So that's going to be 6 pi over 4 plus pi over 4 for a total of 7 pi over 4. And the y coordinate is going to be sine. So we're looking for sine of that. A, B, and C are plotted. What's the coordinates of cosine of pi? So we already learned right here is pi, right? Right at that point, that's halfway across the circle. Cosine's the x coordinate, right? That's cosine. So the x coordinate of C. And then 11 pi over 6. Think about that. 12 pi over 6 is 2 pi, right? So 2 pi, if you remember, is going around the entire circle is 2 pi. Remember, 0 is the start, so we go around the whole circle is 2 pi. So not quite, 11 is not quite 12. So we're right before 2 pi. So C is what we're talking about here. And sine is the y coordinate.